All right, so if you're just coming from my other video, the computer is charging. Everything is good to go for our next few examples. Because in the last video, if you didn't watch it, computer almost died. Would have been pretty great. Anyways, we are still graphing polynomial functions. So we are going to look at g of x equals negative x to the fourth minus 7x squared plus 144. I encourage you to take a moment, pause the video, follow the same 5 steps from video number 1, see how far you can get. If you can get all the way to the end, maybe you don't need to watch the other examples because you've already picked it up pretty solidly just from that first one. If you start a little bit and then you get stuck, watch the video through that point, then pause it again, and then see how far you can get on your own. This type of gradual release is a way for us to see how much we've learned in a very low risk environment. As soon as you are unsure or get stuck, or maybe you do something incorrectly, you can just keep up with the video, identify the error, correct the mistake, and continue on. The earlier you start allowing yourself to try by yourself, the sooner you'll be able to start making those connections and really developing that depth of knowledge that will allow you to know this not just for the rest of the semester, but for many years to come. Again, hashtag cognitive science. Theories of learning are fascinating. Right now, we're still learning about polynomials. So, step 1 is our end behavior. We know our leading term is negative x to the fourth. So as in our last example, n is even, so we know it's going to be the same direction on both sides. And this time, since our term is negative, the right side is going to go down, which means the left side also goes down. So I'm going to, once more, throughout the video, because I don't have a very large workspace, erase as I go. If you need to write something down, pause the video, because I'm not necessarily going to give large amounts of time to write it down, to keep the file size smaller and easier to watch at home. So our end behavior is down to the left, down to the right. We can also really simply and straightforward find the y-intercept, so I'm not even going to write step 2 because we just look at that constant term. So the y-intercept is our constant term because, you know, all of the terms with x's go to 0 when we're on the y-axis. So step 3 is zeros multiplicity, and graph behavior. I'm just going to squiggle there to make it all fit. So that's a graph behavior. Notice that this is, again, in quadratic form, but this time we have a negative out front. Can we use the x method with a negative first term? We can, but it makes it harder. So to get rid of that, I'm going to factor out that negative sign. So every term changes sign. And that will allow us to more easily factor our function. I really wish at times like these, I had a bigger dry erase board. As they say, that matters. So let me set up my x over here, negative 144, positive 7. Well, you pause the video to figure this out on your own. My work from earlier says we get 16 and negative 9. So we have x squared plus 16, x squared minus 9. As we continue on down the line, this part's going to be really simple. In fact, I think we had the same factor in our last video as well. So this will become x minus 3, x plus 3. But I do want to show what happens to this x squared plus 16. If you set up the box, there aren't any factors that multiply to positive 16 and add up to 0. This is going to give us some imaginary roots. So if instead we have x squared plus 16 equals 0, in a few steps, we can see that we will get x equals plus or minus 4i. So our factors will be negative x plus 4i and x minus 4i. And I do just want to clarify that this negative was carried down from the positive from the previous step. It did not come from the imaginary solutions. Our imaginary factors are x plus 4i and x minus 4i because those are the two values of x that we obtain. The negative was just carried down. So our zeros, negative 4i, positive 4i, positive 3, and negative 3. If my dog is being loud enough that you can hear her off-screen whimpering, she is not in any type of danger. She just lost a toy under the bed and can't reach it, and I'm not stopping the video to go get it. So step 2, we're still on step 3. So our zeros, multiplicity, and graph, and I suppose I shouldn't have been so quick to erase the factors because we really should have been looking at that to discuss multiplicity. But again, let's write our numbers in number line order. So negative 3 would come first, then positive 3, and then after that we can write our imaginary numbers because, as hopefully you recall, they don't appear on our graph. They will not contribute anything. I mean, they do contribute things, but nothing that would come up where we can see it. So the multiplicity for each of them was just 1. This is very similar to our last example. The key difference here is that this one had a negative term and we have imaginary solutions. And so together, they're a really good example of how things that might look similar at the beginning can have very different graphs at the end. So when the multiplicity is odd, we cross and cross, but these are not on graph because they are imaginary. So the graph doesn't have any behavior there because there just isn't a graph there. So I'm actually gonna erase that part because I want to use this space for my coordinate plane. Over here, step 4 is plot and label. So the things I need to be able to label on the coordinate plane so that I can plot points at are the zeros and the y-intercept. So 1, 2, negative 3, and this is a cross. Then 1, 2, positive 3. This is also a cross. And then somewhere up here is 144, the y-intercept. Again, the scale on our x and y axes are not the same, and that's okay. So I'm plotting my zeros, plotting my y-intercept, plotting my other 0. And then we know that our end behavior is down on the left and down on the right. Now I have plotted our points and labeled everything. Step 5 is actually drawing in our graph. This is my favorite part. Even though I think factoring tends to be more fun because it's, more like solving a puzzle. Anyways, from our last 0, we go down. That's our end behavior. Notice we have a cross. So we go up, come back down, and we cross again. And notice that our end behavior on both sides match. Writing down our end behavior on the right side is really important because if we start with our end behavior on the left, it's always going to be right, just by default. But we want to make sure our right side is also correct. Because if I did something incorrectly in the middle, so that I ended going up, even though I labeled it going down, I know that I have to check my work. In this case, there were really only 2 points to go through, so there wasn't a lot of places to get lost. But sometimes there can be. So keep that in mind as one way of being able to identify that, oh, I've made a mistake, I need to go back and correct it. It's not a bad thing. We all make mistakes. I make plenty of mistakes. The important thing is that we go back and correct them. Through correcting our mistakes, we not only deepen our knowledge, but also build our confidence and resilience to making the same mistakes again. I just want to point out that even though this looks like a parabola, it is not a quadratic function. It is a degree 4 polynomial. The reason why it only has 2 intercepts is because of these 2 imaginary zeros that don't drastically change the shape of the graph. So yeah, that's pretty much it for this example. The next couple of examples we'll look at odd degree polynomials. These were both even. The next couple will both be odd.